Now continuing on with our Chapter 1 Introduction to Python, we'll continue to look at assignment operators. And this time we're going to look at some augmented assignments in the sense that you can use shorthand to simplify some of the update-like computations or operations that you might do, similar to languages like C and C++. And for example, as shown on the screen here, you could replace updates in the form of A gets A plus B by the syntax A plus equals B. It's just a shorthand notation, like I said, that you may be comfortable with before. You can do the same thing for updates based on subtraction, multiplication, division. Asterisk, of course, means multiplication. The forward slash means division. But I will point your attention to the fact that we saw this last time, that when you have a star star, or at least two asterisks together, what you're really representing is exponentiation. So this update is really of this form. A is getting A to the B power. So that's another way of interpreting A star star equals B. And similarly, the last line, the percent operator, is really the modulus. So in this case, what we're really looking at is updating A with A mod B. So what that means, of course, is A mod B means when you divide B into A and B are both integers, we're looking at the integer remainder that you would get from that division. And that's what A mod B would be. So this is just shorthand notation that you could use to perhaps simplify your programs. Now if we move on from arithmetic operators to comparison operators, you should be familiar with most of these from the languages that you've studied so far in our curriculum. So less than and greater than are what they are. Less than equal to, greater than equal to makes sense. Do keep in mind the meaning of equality when you're doing comparisons, in the sense that if you're trying to compare if something is equal to something, you'll want to use two equal signs. Again, that's very consistent with most of the compiled languages you've worked with. And of course, the last example here reflects not equal. So you have the exclamation mark and equal. So again, let's go back to our Python interpreter and see what some of these simple commands would do. If you were to define a variable A as an integer 3, and B as a floating point number 2.99, and C as a character 3. Keep in mind that this single quote here is an indicator, those single quotes are an indicator that you've got a character. You could use double quotes, of course. And what we're doing here is looking at basically the logical outputs that you would get from comparisons using the comparator and operator. So the first print, for example, is just printing is A greater than B in terms of is that true or false. And of course, A is 3, the integer 3, and it's actually bigger than a floating point 2.99. So basically, that would evaluate till true. But what Python is actually going to print is not T or true. It's actually going to print 1. So 1 is a representation of true in this language. Similarly, if you go to the next line and look at the next print, print A equals C, in other words, is at a true or false statement. In this case, of course, the integer 3, which A contains, and C, which is the character 3, they are not the same. So that would be evaluated to false. However, when you print the testing of that logical expression, then Python does not return false or F or something like that. It actually returns 0. So 0 is taken to be false in this language. The last two examples are just a little more combinational logic using our Boolean and or. You should be familiar with those logical operators, for example. And if you were to test, well, first let's try A greater than B and A not equal to C. And of course, we know from above that this is a true statement right there, and A is certainly not equal to C. We know those are true, and of course, if both are true and you ANDed both expressions, you would get true back, and now we know what Python will print if it's true. It would actually print a 1 for that example. And now if you go to the last one, of course, the combination logic is that this expression we know is true, and a 3 and 2.99 are technically not equivalent, so this is false. But the whole expression is evaluated as true or false. And if one of those with an or is true, then we know that that expression would be true, and this would print a 1 as well. Okay. If this, for example, over here had been something like a less than b, then of course that would have been false, and then both sides of the or would have been false, and we would have gotten a 0 instead of a 1. Now, using conditional operators and conditional type statements is very common. It's a way of controlling the flow of computation and selecting the right kinds of operations or functions to use. This is an example of designing actually a function. We'll get to functions a little bit later, but we're going to actually design a function in Python. And in Python, to define a function, you lead with this keyword def. So that's designating to the interpreter that you're going to define a function. This particular function has the name sine of a, where I'm using the underscore just to make it very readable, and it takes a parameter a. And then the code block that follows the function follows a semicolon. So you always have a semicolon after the parameter list. Now, one thing keep in mind, code blocks in this language are defined by spacing. There are no curly brackets in this language, like C or C++, to designate scope. So you'll notice that all the statements of the function are indented. So that's not magic. That's the way it needs to be. Or the interpreter perhaps will throw an exception or an error, and the error might be due to the fact that you just haven't spaced things over and you have things out of scope. So now that we've got the nature of a function, we're actually adding the contents here. We're testing what the SIGN of a parameter a is. Let's just assume for practical purposes it's a float. And we'll test, first of all, if a is less than 0.0. So an if statement looks very much like most languages. You don't need parentheses around the condition, but you do need a colon following the condition, so the code block would begin for that particular if. What do I execute if this is true? Space over, and so again, here's the code block for that if. It turns out it's only one statement, but it could have been several. Now, if that's not true, then we need an alternative, and in this case, if it's not less than 0, then perhaps it's greater than 0, or it's positive. But notice in this language, it's not an else if. The next combinational logic would be elif. That means else if. So if the first one's not true, then test this if. Else if a is greater than 0.0, again, use a colon to denote the new code block. And if that were true, then of course the sign would be positive. And then the catch-through block, in case the other two are not true, is just our final else, which is consistent with other languages. And again, do keep in mind each block is being started with a colon. It's something easy to forget, but something you just have to get used to. And of course, if the previous two are not true, then it must be 0. And this particular function is returning a string, and the string is either going to be neg, POS, or 0. And then down here at the bottom, what you're seeing is just an illustration of the use of this function. We set a variable a equal to 2.0. It's a float. And what we do is we print, first of all, string. So we're going to print, with a space is space. Actually, I'm not going to have a single quote there. It's just going to be a space is space. Then we concatenate whatever that function returns. It makes sense to the interpreter because that function is returning a string. So as long as it returns a string, it knows how to interpret the plus. And of course, for this particular example, it's going to return what? Well, if you go through the logic, it's definitely going to return POS. So this little example will return a space is space POS, which would stand for positive. Loops. Certainly conditional operators are very important to control loops. And here's an example of a while loop in the Python language. Couple of things, again, keep in mind the indentation of the code block to define the scope of the while. What are the statements that belong to the while? And again, the condition follows the while, and then the block is led. Sorry, the block is led by the colon there. In this particular example, we're generating a list, and we would start off with an empty list. And this is one way of starting off an empty list, is just to define it as 2 square brackets. So there's no contents in that list. It's empty as far as the interpreter is concerned. And then what we're going to do in this case is, actually I've skipped ahead, let me go back. There we are. I was looking at the for loop. Let's go back to the while loop. Got a little bit ahead of myself. Back in the while loop, we're going to build the list. Here's the empty list, and we will execute this condition, and while it is true, we will execute this while loop and build this list. So let's think of the logic here. We're going to initialize n to be 1. We're going to be testing whether it's less than n max. N max is 4. So while that condition is true, execute the following statements in the code block, following that colon. So what does it do? Well, A is a list. The interpreter knows it's a list. It has built-in functions. They're applied to that list with the dot. So it says append to A 1.0 divided by n, which would be interpreted as a float because one of the operands is a float by definition 1.0, even though the denominator is integer, but it would promote the result to a float. It would cast it to a float. So in the first case, what would happen is if we were thinking what's going to happen to A, let's go back. Let's see what would happen to A. Well, A would start off as an empty list, and then after it executed the first part of the code block, it would test, let's see, 1 is certainly less than 4, append 1.0 divided by 1, so the list would actually would grow, and it would grow to have one element. It would be 1.0. And would it keep growing bigger? Well, n would be incremented by 1, so n would become 2, and then 2 we would test to see is 2 less than n max, and of course the answer is yes. And so then what will he append to the list A? We're going to append 1.0 divided by 2, which for all practical purposes is a half. So the list would grow, and we would have 0.5. And then n would be updated to 3 because of this update statement there. And of course that could have been written as n plus equals 1 using our shorthand notation. But it's not, and that's fine. So then we come up and test is 3 less than 4? Yes, and so I think you see what would happen. It's going to append a third, but I'm going to have to write a third, and I'm just going to write the fact that that 3 repeats, and it just depends on the precision of the interpreter that it wants to default to in terms of how many 3s it would print. And then 3 would be updated to 4, and you would test is 4 less than 4, and of course the answer would be no. So the code, the while loop breaks and falls back to whatever is next in the program, which would be the print. So it would then print A out, and what you see there on the screen right here is exactly what you would get on the output. That's a while loop with a very simple condition. Now, this is the same approach to build the same type of list, but now this is using a for loop. And I want to point out some features here. So we've already seen how to initialize an empty list, and certainly we're going to use a boundary value of 4. The goal of this list is to generate 3 items. For loop is based on the keyword for, which is consistent with most languages, but what follows is different, very different from C and C++. You have to have an iterator variable. In this case, it's n, and in this case, what we get here is the statement for n in the range 1, n max. Range is a built-in function that Python uses to generate a list, and that list is iterated by that variable n. So let me say that again. Range is going to return a list. You're giving it a starting value, and you're giving it a boundary. It's very much like that slicing thing again, where what range is going to do in this case is return a list of integers starting with 1, going up to but not including n max, which in case is 4. So it's very consistent with the slicing discussion we talked about earlier. So ultimately what the range is generating here is a list that starts at 1 and increments by 1 until we hit the boundary of 4. In other words, we can't get to 4. So what that does is it generates a list 1, 2, and 3 to be iterated by n. So what we're saying is for n in this list, where n marches from 1 to 2 to 3, do this operation, which is append. And of course, this would return the same thing that we had a minute ago in terms of the 1.0, 0.5, 0.333 on 3-element list. So what the complicating factor here is just getting used to this idea of functions that are going to generate all the values that you need for your iterator inside the for. And so the range is a very powerful function to do that for you, and it's important to be familiar with it. Any loop can be terminated by a break. If you hit a break anywhere in that code block, it would terminate it. You have to be careful about that in terms of potentially causing errors and creating misrepresentations of your data structures that you're working with. But it can terminate with a break. Otherwise, it's got to run through. In this case, it's got to run through that entire list for n before it can terminate. Very different from a while loop. This is a nice little example that kind of puts it all together a little bit. It's a little more complicated program. We're not defining a function, but we're just going to take a list and basically just find out if an element is in the list. And it's also got some nice new functions that are going to be very important in terms of I/O a little bit later. So here what we're doing is we're going to define a list of 4 elements, and each element is a character. And of course, it's, as you see up here at the top here, that is just A, B, C, and D. Very simple list. Now here's a function we've talked about, the length of the list. If we wanted to get the length of the list, we could call len immediately because I don't need to have the user tell me what the length of the list is, like some languages might need to do. It'll tell me automatically that in this particular case the length of the list is 4. So I'm just going to write a 4 here to indicate that that's really what bound is going to store, even though you could accept any particular input list there and be just fine. Now, the next, there's actually two functions you see in the third line. There's one called input, which you see here, and then there's another called eval. Right? So let's start off with input. Input is basically the function to grab data from the user on the keyboard. In other words, the user is going to provide you data on a prompt. And what you pass to this input function is the prompt that you want to give the user. So what's it accepting is actually a string. So I'll say this again. So you're providing a prompt. In this case, here's what the prompt is. You're telling the user, type a character, please. There's a space so that the cursor would actually be a space away from that colon. And you asking the user, type a character, and then the user types something. Okay. All right. So that would then grab that input, and what the next function does, I should say, what that function is going to do is it's going to take whatever the user types on the screen and convert it to a string. That's consistent with a lot of languages like C and C++ because we want the most general representation of what the user is typing, and then we'll go back and convert it to whatever we need it to be in terms of computation or comparison. So that's exactly what eval is going to do. The user is going to type a character, and the eval is going to convert it appropriately to a character. In this case, we call it char input or character input. So, for example, if you were working with numerical data and you ask the person to type an integer and you want to work with an integer in your code, you need to use the eval so it will convert that input that the user provided from a string to an integer. Okay. So then in this case, we use a for loop in the range of the bound, which means we're looking over the elements of the list. And so here's a call to range with only one parameter. Now, remember in the previous slide, we had 2 parameters. So let's think about what the difference here. So over here, I'm going to show you the difference. If I called range, and I had range with two parameters, 1, 4, a starting value for this list of integers I want to generate, and the boundary value, which means I don't include it, you'll recall that that would generate a list which is really 1, 2, and 3, starting at 1, but going up to, but not including 4. If you passed just one parameter to range, so it's overloaded in a way that if range was only passed one particular one integer, 4, the question is now, what does that mean? Well, in that case, the default start is going to 0. So if it only has one parameter, it looks at that parameter as the boundary. It will think that, okay, that just means I always start at 0. So in this case, what it's going to generate is actually a larger list because it thinks it needs to start at 0, then go from 0 to 1, 2, and 3, but do not pass 4. So there's the difference. If you pass one integer to range, the assumption is that the list is starting with 0. So if you're indexing an array or something, if you're doing 0 indexing, that's just fine. But if you don't want to start at 0, then you need to do something like we did before and use two parameters with the first parameter indicating the starting. So in this case, if we go back to the for loop, I is going to run over this particular list of integers, 0, 1, 2, and 3. So there's going to be 4 iterations of that for loop, and basically we're just testing if a list item is equal to the character input. This is not a very particularly efficient code right here. We're just using it to illustrate some syntax and put some of the commands, the functions together that we've talked about. So we're just testing whether the element of that list, the current whatever I is pointing to or storing, is equal to whatever the user typed. And of course, what the if does, again, keep in mind all the code blocks are indicated by spacing. Python is forcing you actually to write some very nice structured code. And what you've got here is testing, again, if list of I would start off with 0. If list of 0 is equal to the character's input that these are provided, then we're going to print it, and then we're going to print the position in the list. But we're using positions that a human would be comfortable with, not 0 indexing. If it's the first one, we'll put 1, and that's the reason why we're going to print I plus 1 rather than I. And if we found it, then here's an illustration of the break. The break there would kill the for loop completely. Okay? The break there is not to break the if, it's to break the loop. It's to break the for. And then, of course, the alternative is, well, if it's not equal to, if the current list item I'm looking at is not equal to the user's output, then I'm going to continue to search for it. In this case, we will reset I to be bound -1 and say that the character is not in the list. Okay, as if I can go through, I guess I should qualify. If this else loop is depending upon whether or not I have found the element. It's not, again, this is not a particularly great code here, but if it was in the list, if it was the first position in the list, I'll print it. If it's not, I'm going to test if I'm at the end, if I've searched through the list, because if I is equal to bound -1. Right. In this case, if it's in position 3, then I must not have found it. Okay, because that means I has iterated completely through that list from position 1, 0, 1, 2, and 3. That's clear. I think the code is fairly straightforward. Down at the bottom, what we've got is just executing this code, assuming that the user has typed an A or an E. All right. So even though I've got single quotes listed there, the user can just type the letter, and so, but that's illustration that what they're typing is going to be converted into a character from the code up there, And if you just play the logic of it, when we type in the A, it's going to find it, and it will find it when I is equal to 0 right off the bat. And so the output that you're going to get in that particular case is it's going to be the statement A is in position. And again, for the human, we're going to increment by 1. So we're going to say position 1 in list, right? If we just look very carefully at the statement, the character string, the string that's actually in the print. And of course, I've done the other example where it's going to keep iterating over that list, checking if the current list item is equal to E in the second case, and it's not going to find it because I is going to become 3, and if I is equal to 3 and it was never found, which means it got to the else part here, then it would basically print the same thing, but the sentence actually would be E is, let's try to print it better here, is not in the list. Okay. So that's that would be the output of that program. Type conversions. Sometimes it's very handy because data might come in different forms, and it might be necessary to do type conversions. There are built-in functions such as int, long, float, complex, and complex A and B. So some of these would make sense to you automatically just based on what you know of other languages, but some might be different. So here's an example. Suppose A had the integer 6, B was the float negative 2.5, and C was actually a string 4.0. Again, notice the single quotes. And so that if I was to print A plus B, in the sense of the fact that I've got 6 and then added to negative 2.5, it's what you'd expect the output to be. It would be, oops, I'm sorry, the output would be 3.5, right? So that would be the output for that particular example. And if you took the floating point B there, negative 2.5, and did a type conversion call with the int built-in function and said int B, what would happen is it would truncate the fraction. That's the reason why I've got the comment, think truncation. Do not think rounding. So in this particular case, what that print is going to return is a -2. All right. Complex numbers can be built, and this is important in many scientific applications where you may have roots of a polynomial or other types of needs where complex numbers come in play and you need to represent them, and Python can do them very, very easily. So you can actually use the complex function to accept 2 parameters, one for the real component, which is what A would stand for, and B for the imaginary component. But I want to show you what you would see on the output, which might not be what you'd expect. A complex number is actually written with parentheses to indicate it is complex, and it would be written in this case as 6 minus 2.5. And I know you're thinking I, but actually they use J. In a lot of engineering applications, it's I has other meanings, and it can get confusing, and so they tend to use J to represent the complex, the numbers as part of the imaginary component of a complex number. So you would actually see 6 minus 2.5J. Now, if you went on and looked at the other examples, you can take the string negative, which is stored in C, which is 4.0, and actually pass it to the float function, and it in fact would convert it, which is very nice. So it actually would convert that to be the floating point value 4.0. Just basically you can imagine that what it's going to do is going to strip off those single quotes. The last example is a little bit more complicated. It turns out you can't directly cast that string 4.0 to an int. it's going to have a problem with the fact that you've got a representation actually inside those single quotes of a float, not an int. So this particular example will fail. This would generate an error because it can basically understand the meaning of converting or pulling off those single quotes and converting to whatever it is. But if it doesn't see that as an integer at all when you remove those single quotes. So this is just an exception you have to deal with, that you're not, there's other ways of converting that to an integer, but not this way. And of course there's some other very useful mathematical functions that are useful. Absolute values, certainly, max and min are very useful. If you do need to round up to a certain number of positions or digits, that's useful. And there is a comparison operator, and I want to talk a little bit about what that is, how that really works. So again, before I forget, this rounding means the number of decimal places you use on the rounding. So that's the number of decimal places. Okay. The comparison function here basically returns either -1, it returns 0, or it's going to return 1, positive 1. And it returns those according to different relationships. In other words, it will return a -1 if A is in fact less than B. It will return 0 if they are equivalent. And it will return 1, guess what, if A is greater than B. So sometimes it's important maybe to write that in terms of some conditional, in terms of the comparison of those two integers. And that's what it'd be. All right, we're going to stop right here before we move on to I/O, which is a very important part of the language. But at this point, we've covered a lot of the control structures, comparison, some other ways of expressing arithmetic operators. And in the next video lecture, we will look at input and then get more into functions.